Okay, here we go. Video 3 for U substitution. Today we're going to talk about antiderivatives that involve inverse trig functions. Alright, so you remember from first semester that when you took the derivative of the inverse sine, you got this 1 over the square root of 1 minus x squared. So what we know about antiderivatives, it would make perfect sense that if you took the antiderivative of 1 over the square root of 1 minus x squared dx, you would end up with sine inverse of x. Okay? Let's look at an integral, a definite integral. What about if you have the definite integral from 0 to 1 of 1 over x squared plus 1 dx? You would remember, this would be up in your head, that when you took the derivative of the inverse tan of x, you got 1 over x squared plus 1. Okay, so with that in mind, you would say, oh, this is nothing more than the inverse tan of x evaluated at 0 and 1. And what that's asking you to do is to find the angle whose tangent is 1 and the angle whose tangent is 0 and subtract them, and you've got those exact values right on the top of your head ready to come out, and you've got pi over 4 minus 0, and final answer is pi over 4. Okay, so you're thinking, but what does this have to do with U substitution? And I'm so glad you asked, because here we go. So let's look at this problem. What about if I have the integral x over x to the fourth plus 1 dx? So you might be saying to yourself, well, that doesn't look too tricky. I'll just pick u to be x to the fourth plus 1, which means that du equals 4x to the third dx, or x to the third dx equals 1/4 du. The problem is you can look for a long time at this integral, and you will never find a place that you can substitute for x cubed. Alright, so first thing I need you to know is that doesn't work. Alright, so what we're going to do instead is something a little trickier. We're going to go ahead and let u equal x squared. Alright, and so the reason we pick u to be x squared is because we know that x squared squared is x to the fourth, right? So let's go ahead and finish this u over here. I've got 1/2 du equals x dx. Alright, so x dx, got it right here. So this becomes the integral, 1/2 du, and then I have 1 over, and instead of x to the fourth, I'm going to call that u squared plus 1, right? Because u is x squared, and so u squared would be x to the fourth, right? So these problems are not challenging as long as you recognize that this is the pattern. Alright, so we know that this is just nothing more, the integral of this is nothing more than the inverse tangent of u. And because it's an indefinite integral, we go back to adding c, and then the final thing we have to do, because it is an indefinite integral, is return back to the x squared, and there's our final answer. Okay, how's that look? Let's do one more, this time with an inverse sine, and see how that goes. So this time my integral is dx over 1 minus 16x squared under a square root. Alright? And so again, we could try to pick, we might say, oh, I got it underneath in the denominator of the fraction, and it's underneath the square root, so u has got to be 1 minus 16x squared. But then when you try this, what you get is negative 32x dx. And see that x there? Again, you're not going to find it in the integral. So you know you've got to try something else. Earlier, I think in the very first video, I said the way you get better at doing this U substitution is doing a lot of different problems, because everyone's just a little bit different. Okay, so think about what you might pick to be U, so that the model we're thinking here is that inverse sine, which is 1 over 1 minus x squared square root. Okay, looking at that, I'm hoping you're saying to yourself, oh, I bet that u should be 4x. And why is that? Because 4x squared is 16x squared. Get it? I hope so. All right, so now I've got 1/4 du equals dx, and this integral now becomes the integral of 1 over the square root of 1 minus u squared du. Okay, because here is du, that's the dx, and then 16x squared is u squared. Oh, I made a mistake here. Watch that. Gone. U is not 4x dx, it's 4x. Okay, so let's go back over that again. If u is 4x, then du is 4 dx, and 1/4 du is dx. When I substitute in here, the 1 minus 16x squared becomes 1 minus u squared under the square root. All right, we're almost done. The integral of that is nothing more than the inverse sine of u. Oh, don't forget the 1/4. Don't forget the 1/4 plus c. And then because it's an indefinite integral, the last step that we have to take is to replace the u, and we get 1/4 sine inverse of 4x plus c. And that's it. Okay. I hope that these u substitution videos have been helpful, and see you in class.